For our next problem, take a moment and read through problem number 13. And we need to try to draw a picture here. So let's see. We've got a light at the top of a 16-foot pole. Okay, so here's a pole, there's a light. See it shining, wonderful. That is 16 feet tall. We have a boy walking away from the pole at a rate of 4 feet per second. So here's a boy. Let's see, he's walking away, so he's going to be pointing in that direction. And he's 5 feet tall. At what rate is the length of his shadow increasing when he's 18 feet from the pole? At what rate is the distance of the tip of his shadow from the base of the light post changing when he's 18 feet from the pole? Okay, there's a lot going on here. First of all, the way lights on posts work is it shines over here on him, and it's going to create a shadow down here. In fact, let me draw out kind of the rays from the pole. I'm going to make myself a nice little triangle over here. His shadow is over here. And as he walks, the shadow is going to get bigger. And as he walks also, the distance that he is from the post is changing. I'm going to put some variables over here. I'm going to say this is x, and I'm going to say this is y. Let's ignore that second question and just focus on the first one. At what rate is the length of his shadow increasing when he is 18 feet from the pole? Well, if the boy is walking at a rate of 4 feet per second, his distance from the pole is what's changing at 4 feet per second. I know dx dt equals 4 feet per second. In part 2, I want to find the rate of change of the length of his shadow. I want to find dy dt. When he is 18 feet from the pole, so when x equals 18. But I never created the formula that will relate the x and y. And what we need to use here, as the title of this section might suggest, are some similar triangles. Let me show you what I mean. I've got one triangle over here. I've got another triangle over there. That small triangle has a base of y and a height of 5. The bigger triangle has a base of x plus y. And because they're similar, I'm going to set up a ratio. I'm going to say, let me come over here to do my work. I'm going to say y over x plus y equals 5 over 16. That is going to be a pain to use, so how about I cross multiply and make this look nicer? I can say this is 16y equals 5x plus 5y. And why don't I just get the y's together on one side, because I can, and I can say 11y equals 5x. And this is the formula I'm going to use, which is actually going to be a really nice formula to work with. I'm now going to find the derivative. Derivative of 11y is 11 dy dt. Derivative of 5x is 5 dx dt. I'm going to plug in my 4 for dx dt, and actually I'm basically there. There's actually no place at all to plug in the 18 just because of how these things are related and how they're changing. dy dt, the rate of change of the length of his shadow is 20 over 11. Things are being measured in feet, so distance is feet. The time is measured in seconds. So the shadow is increasing at a rate of 20 over 11 feet per second. As for part 4, not part 4, sorry. There is no part 4. I already have my answer. I'm done. But there was another question here that I'm going to call part B. Whoops, you can't see that. I'm going to call that other question part B. The rate that the distance of the tip of the shadow from the base of the light post is changing. The tip of his shadow, how far is this from the base of the light post? Well, how far is that from the base of the light post? I think it's x plus y from the base of the light post. So I want to find d, this is going to look weird, the derivative of, well, that x plus y. This is going to be dx dt plus dy dt. I was told dx dt, that was 4. I already found my dy dt, that's 20 over 11. Add these together, you've got 44 over 11 plus 20 over 11, and you're going to get 64 over 11 feet per second.